4.5 billion years ago, there was no blue planet, no forests, no oceans, no life. Just this, a newborn world still glowing from birth. Mountains of molten rock, skies choked with poisonous gas, a constant rain of asteroids turning the surface into a planetary firing range. This is where the story of life begins. But how does a world like this become our home? The sun is young. The solar system is in chaos. Fragments of rock and ice slam together, drawn in by gravity. Out of this wreckage, one planet slowly takes shape: Earth. Still, this is not a world we would recognize. The surface is a rolling ocean of magma. Temperatures soar. No liquid water can survive on the surface for long. But deep beneath the violence, the foundations of a future world are being laid. In this early chaos, a new catastrophe strikes. Another planet collides with the young Earth. The impact is unimaginable. Rock vaporizes, entire layers of the planet are thrown into space. From this debris, a new companion slowly forms: our moon. The collision remelts Earth's surface, creating a global ocean of lava yet again. But as time passes, the planet cools. A thin crust hardens. Volcanoes punch through it, releasing steam and gases. Outgassing from these restless volcanoes will one day build an atmosphere, and the steam will become something vital: water. Clouds gather in a sky thick with carbon dioxide, methane, and nitrogen. There is no oxygen, no ozone layer. Unfiltered radiation from the young sun beats down. But as the planet cools, something extraordinary happens. Water vapor condenses. For the first time, rain falls on Earth. At first, it simply boils away on the still hot surface. But the cooling continues for millions of years. Eventually, the rain no longer evaporates. It pools in low places, flooding basins and craters. The first oceans are born. They are dark, acidic, and filled with dissolved metals and minerals, hostile by our standards. But compared to the searing rock that came before, these oceans are a revolution. In these young oceans, and along the still smoking coasts of newborn continents, the ingredients of life begin to gather. Volcanoes pump gases into the air: carbon dioxide, nitrogen, sulfur compounds. Lightning splits these molecules apart and recombines them. Asteroids and comets deliver water and organic molecules from space. On the seafloor, hydrothermal vents belch superheated, mineral-rich fluids into the deep. Along the shoreline, small pools fill and evaporate, concentrating simple chemicals into thicker soups. Everywhere, energy is abundant. Heat from the planet's interior, lightning from turbulent storms, ultraviolet radiation from the sun. Under these conditions, simple carbon-based molecules begin to form and accumulate. Amino acids, simple sugars, fatty acids, building blocks. They are not yet alive, but the line between chemistry and biology is starting to blur. No one was there to witness it. We cannot rewind time and watch. But by studying ancient rocks and recreating conditions in laboratories, scientists have pieced together possible pathways from simple molecules to something more. Perhaps, in deep-sea vents, mineral surfaces acted like natural laboratories, concentrating and organizing molecules, letting them react again and again over millions of years. Or maybe, in shallow pools that repeatedly filled and dried, chains of molecules formed, broke apart, and formed again, each cycle creating new combinations. In countless tiny pockets across the young Earth, chemistry was running experiments. Most of these experiments led nowhere. But over immense spans of time, some combinations gained a powerful advantage. They could make rough copies of themselves. Imagine a molecule that can store information and help create copies of itself from the chaos around it. Something like this may have emerged on the early Earth, perhaps based on RNA, a cousin of DNA, or on some simpler ancestral system that left no trace we can see today. These primitive replicators were not alive in the way we think of cells today. They did not think, move, or breathe. But they had something new: heredity. Copies that were almost the same, but not quite. Those tiny differences meant that some versions copied themselves faster or survived longer in hostile conditions. For the first time, a new force appeared on Earth: evolution by natural selection. From this moment on, successful chemical systems would spread. Unsuccessful ones would vanish. And slowly, step by step, random chemistry was being replaced by something more organized and more persistent. Even as these early replicating systems appeared, Earth remained a dangerous place. Asteroids and comets still crashed into the surface. Some impacts were so large they could vaporize oceans, sterilizing huge regions of the planet. Intense ultraviolet radiation beat down on shallow waters. Volcanoes reshaped landscapes, poisoning some environments, opening new ones. Any fragile progress could be wiped away in an instant. But these processes played out over millions of years, and time was the ally of chemistry. Given enough chances, enough environments, enough constant mixing and cycling, the odds of complex, self-sustaining systems emerging grew steadily. Somewhere, perhaps in many places at once, the first primitive cells were drawing near. From the outside, this young Earth still looked hostile. A world of storms, volcanoes, and no visible life. But in its oceans, the planet had already achieved something monumental. It had cooled enough to hold liquid water. It had gathered and concentrated the basic ingredients of life. It had provided energy sources and countless tiny habitats for chemistry to explore. Every tree, every animal, every person who will ever live depends on this early chapter. Without a stable crust, without oceans, without cycles of heat and cooling, the story of life could never have begun. Our planet had moved from a molten rock in a violent disk of debris to a world ready for life to appear. Somewhere in these ancient seas, the first true cells will soon emerge. Tiny, simple, and alone in an empty world, but unstoppable once they arrive.